Hi, everyone, and welcome to our podcast on climate engineering on Mars. My name is Jessie.
Andrew.
I'm Zahra.
And I'm Flavia.
Today we're going to be covering different aspects of climate engineering on Mars. Specifically, we'll touch on the overall Mars atmosphere and its Earth system relations. Afterwards, we'll go over what exact conditions are needed for a future human colony to be able to thrive in such a different environment. Finally, we'll go over climate engineering technologies that can secure a Martian future and the importance and reasons behind interplanetary colonizations. So firstly, how does the Martian atmosphere affect our efforts to climate engineer the planet?
So one of the key steps, if you want to, for example, terraform Mars, is to give it an atmosphere, or a substantial one at least, because Mars already has somewhat of an atmosphere. But it's around 1/100th of the pressure of Earth's atmosphere, and mainly composed of CO2. So approximately 1 million years ago, Mars had an atmosphere akin to that of Earth's, maintaining around 20 degrees Celsius with a similar pressure, and it allowed liquid water to exist on the surface. So they had lakes and rivers and stuff. And of course, these conditions are needed if we want to, for example, walk on the surface with a spacesuit and grow plants and many other things.
Right. So why does Mars no longer have an atmosphere?
The reason for Mars's previously dense atmosphere is why Earth has an atmosphere today. It had a magnetic field, but it disappeared around 4 billion years ago, which has caused a deterioration of its atmosphere ever since.
Interesting. So how long until it's all gone?
Well, it's been calculated that in around 200 or 2 billion years, if for some reason the atmosphere is replenished, it will
I see.
dissipate.
So how does a magnetic field protect the atmosphere?
So without a magnetic field, solar winds will strip the atmosphere of its components if it's not shielded. So, and solar winds consist of extremely fast-moving particles, which, upon collision with gases in the atmosphere, will send them shooting out into space. If solar winds are detected before that happens, this decay will happen at a much slower pace.
I see. So what is the mechanism that's at play here?
So the solar winds, like I said before, consist of fast-moving charged particles, which means that they generate their own magnetic field. And Earth's magnetic field, is generated by convection currents of liquid iron nickel in the core. And this magnetic field repels some of these charged particles out into space and keeps them from entering Earth's atmosphere. But the disappearance of Mars's magnetic field still remains a mystery.
All right, thank you, Andrew. Let's move on to the next part. In this section, we'll be discussing how Mars relates to Earth systems and the various similarities and differences they share, as Mars is the most Earth-like planet.
Now let's go over why Mars would be a good candidate for future colonization for us as humans. You mentioned that it's the most Earth-like planet. Can you please elaborate on that for us?
Yes, of course. So similar to Earth, Mars is a terrestrial planet, which means that its core makeup is very similar in composition to that of Earth's. Mars also has a solid, dense metallic core, an overlying mantle, and with a less dense crust, which makes it a prime candidate for us to inhabit.
Interesting. How about the most notable differences between them?
Right. So there's also definitely major differences in their surfaces. So while 71% of Earth's surface is covered in water, there's currently no known liquid water on Mars. In fact, its entire surface is very dry and dusty, which would probably be one of the biggest challenges for a future human colony.
All right, thank you, Zara.
Although Mars has some similarities with Earth, such as having a dense core, Mars surely is different from Earth in terms of surface composition. Why would you say we are considering colonizing Mars given these such harsh conditions?
Mars does have an extremely harsh atmosphere for all of the reasons mentioned before. Because of this, it would be extremely hard to sustain life and thereby humans on the planet. However, there are also reasons to support colonization there. In contrast to every other planet in the solar system, it seems to be the most suitable for a first step towards outer Earth colonies. The reason why Mars is the main focus of future interplanetary colonization is because of its similar conditions to Earth relative to any other planet in the solar system, specifically regarding its temperature and sunlight. However, before we can even consider what engineering or technology we will need to create in order to colonize it, it's crucial to understand specifically the conditions needed to sustain life on Mars.
So if that's the case, then what are these conditions that we need to sustain life on Mars?
Well, first to answer that, we need to analyze what the dangers are to humans. These dangers can be subcategorized into short-term and long-term dangers. The short-term dangers include radiation, reduced air pressure, and the presence of only 0.16% oxygen in the atmosphere. Because Mars has a weaker global magnetosphere than Earth, a great amount of radiation reaches the surface in the form of galactic cosmic rays and solar energetic particles. Therefore, if a colony of humans were to live on Mars, there would need to be technology to protect astronauts from radiation. Similarly, the low air pressure and low oxygen are not compatible with our respiratory systems and would quickly endanger any human in such an environment. However, even with solutions to such short-term dangers, there are also long-term ones that would make future life on Mars difficult to adapt to. For example, the comparatively low gravity of Mars could cause health problems such as muscle loss and bone demineralization, both of which have been seen in microgravity conditions in astronauts. Similarly, future farming for colonies will be difficult because of the toxicity of the soil due to high concentrations of chlorine.
So if there are so many dangers to human, then how is it possible to colonize it? What will we need to do in order to live there in the future?
Well, there will need to be adequate preparation by technology and engineering for these harsh conditions astronauts will need to face. It is extremely important that we figure out not only how to tolerate these short-term conditions to endure temporary travels, but also the long-term ones to ensure success on the planet as a future home. All of these problems can be fixed with technology that already exists. We just need to thoroughly and meticulously plan these future engineering endeavors.
Now, we've discovered some differences between Earth and Mars. Mars has some toxic conditions for colonists due to its thin atmosphere, resulting in excessive radiation, as well as the disappearance of a magnetic field. With these Martian conditions in mind, we're going to talk about the climate engineering technologies that can hopefully make Mars habitable as it was before.
So the first technology that I would like to introduce is the solar reflectors, and it's also the one that SpaceX founder Elon Musk mentioned back in 2018. As the name suggests, these reflectors will orbit around Mars and reflect solar radiations onto the surface, as the figure 1 shows on the screen. This would eventually melt the ice cap and release the carbon dioxide that was trapped inside, creating a greenhouse effect.
So the greenhouse effect that is causing problems on Earth can be helpful on a different planet?
Yeah, especially for a cold planet like almost no atmosphere like Mars. This would eventually thicken the atmosphere and increase the pressure of Mars.
Is there any data that tells us how significant that would be?
Yes, of course. So some research papers suggest that it will eventually raise the surface pressure by 300 millibars, which is equivalent to 30 kilopascal. The overall temperature will also rise by 4 Kelvin or 4 Celsius.
Given that rising the global temperature by only 1 degree is considered very significant on Earth, this would have a great impact on Mars. Now, let's talk about its feasibility. Do you believe that this can be implemented soon?
Yeah, as of now, due to limited resources and energy, engineering feasibility remains a bit of concern. It is predicted that the reflector themselves will weigh over 200,000 tons, and as you might know, there's no launching technology available yet to launch that heavy object from Earth.
I see. In that case, what's required to make it work soon?
So in the future, probably space-based manufacturing technology will be very essential. By space-based, I'm talking about using some asteroidal or moon materials as the reflector's major components. And as for the energy, it could be provided by nuclear reactors that have a power of over 120 megawatt years, which is about the same energy as 5 little boy nuclear bombs from Hiroshima.
That sounds very cool. Do you have any other climate engineering technologies to talk about today?
Yes. So one other technology that NASA scientists were mentioning about is an artificial magnetosphere that can be placed at the L1 Lagrangian point of Mars to reduce the impact of solar winds and eventually increase the pressure and the temperature.
Can you elaborate more on the Lagrangian point? What does it do and why is this an optimal place?
Yes, of course. So L1 is the point where the gravitational pull of the sun and Earth cancels out. It is where the early warning systems to monitor Martian storms is placed. So this image, figure 2, shows the exact location of L1 over here.
And do you believe that this will be feasible one day?
Yes, I believe this is certainly feasible one day. So with the ongoing research in plasma physics, the possibilities of generating an artificial magnetic dipole field remains very promising. And I hope I can update you more on the research next time.
That was great. Thank you, Jessie. Given how difficult these technologies are to implement, what are our motivations behind creating a colony on Mars? What is the importance of achieving this goal?
That's a great question, Flavia. First of all, we need to think about our current situation. So as we've seen recently in the past 10 or so years, we know that pollution on Earth continues to be a bigger and bigger issue. It's not decreasing, and its effects are consistently getting worse.
Right, and if we keep that up in the future, this will become a completely suitable place for humans to live on. We want to ensure the continuation of human life by creating a colony on Mars in the event that Earth becomes unsuitable for us to inhabit.
Yes, that's for sure. We're also very interested in building a colony on Mars, as it would allow us to explore an entirely new type of landscape and expand the horizons of current technology with new information.
So today we learned about some similarities and differences between Mars and Earth, how Mars lost its atmosphere and its influence on terraformation. We also learned about some conditions that are needed to sustain life on Mars due to its toxic condition, including radiation, low pressure, and high soil chlorine concentration. Then we also discussed 2 climate engineering technology, artificial magnetosphere and solar reflectors that can make Mars habitable once again. These promising technology also reveal that further research is crucial. Thank you for listening and tune in for next week's Climate Engineering on Venus.